Welcome to the workshop. Today we want to continue taking a look at section 6.2, which is about logarithmic functions. In particular, we started taking a look at the derivative and the integral of the logarithmic function, or when we would end up with the logarithmic function rather. So let's take a look at our lecture notes. We started taking a look at examples, and we want to continue taking a look at those. So again, log rule for integration is what we're taking a look at now. And we're using essentially this theorem. Either we explicitly have the integral of 1 over x, or we're going to make some substitution so that we have the integral of 1 over u, du, of course. So we want to make use of that. So we did that in two examples here. And then in this example, this was almost more about polynomial division and synthetic division than it was the integration itself. But here, what I would encourage you to do if you were unsure about this polynomial division, what was going on there, I would encourage you to take a look at some YouTube videos. I don't have any posted myself, but there are plenty out there regarding polynomial division and synthetic division. So feel free to watch those. You will see a couple problems like this in your homework and possibly on exams. All right, so continuing on to another example. Here we have something that's maybe not quite so obvious as to how it might turn out. All right, or it's, I mean, there's some directions here, but not super specific. So find the indefinite integral by making a change of variables. And so if we want to find this with a change of variables, we have to decide what we're doing. What are we substituting? So we want to make some sort of a decision. We want to say, let u be equal to something. What? Not sure yet. Have to decide. Well, probably the easiest way to go here is to actually consider replacing the denominator. If I scroll up here and we look at the polynomial division, right, this involved a lot because it was x plus 5. If it were just x in the denominator, this division would have been very easy. So we could give it a try and say, let u be the cube root of x minus 1. And why do I view it that way? Well, when you're performing a substitution, sometimes it's a little bit of a guess, and sometimes it's, hey, I know where this is going. But generally, I've heard it said that you can try to replace the most complex thing with the variable u, right? Which piece is the most complex here? So is the cube root of x the most complex thing, or is it the cube root of x minus 1? Well, I would argue the cube root of x minus 1. Nothing's horribly complicated here, but to me, that makes the most sense. So x to the 1/3 minus 1, just observing the power here. So that way it's a little bit easier to follow where du comes from. Bring the power down in front, 1/3. Let's see here, x to the negative 2/3 dx. So I definitely don't have 1/3 x to the negative 2/3 dx here. But what I can do is I can create it. So let's see here, moving this guy over a little bit. This is going to be equal to the integral of, now I'm going to do a few manipulations here. So this is x to the 1/3 divided by x to the 1/3 minus 1. There we go. And I need 1/3 x to the negative 2/3 dx. So I have the dx already, but I don't have this. So I'm also going to multiply by 3x to the positive 2/3. So now the 3 and the 1/3 cancel, the x to the 2/3 and x to the negative 2/3 cancel, and we have exactly what we started with. But now I can pull that 3 out in front of the integral. I need the 1/3 to stay inside. X to the 2/3 times x to the 1/3 is just x. And in the denominator, we still have x to the 1/3 minus 1. And this is 1/3 x to the negative 2/3 dx. So I haven't done much, right? I just rewrote it so that way I can see what I have. Now I know what to replace x to the 1/3 minus 1 with. That's just u. But x itself, I don't have. So what I'm going to do is I'm going to go ahead and if I have that u, I'm going to solve for x. So if I have u is equal to x to the 1/3 minus 1, of course, I'm solving for x in terms of u here, so I can make my substitution. So x to the 1/3 minus 1. Let's see here, add 1 to both sides. U plus 1 is equal to x to the 1/3. And then cube both sides to get u plus 1 cubed is equal to x. So now I know what x is in terms of u. I know what this is in terms of u, and this is just du. So I can make my replacement. So this is 3 times the integral of u plus 1 cubed divided by u times du. So now I have an integral in terms of u, and it's just, right, it's very similar to our previous problem, polynomial division. But this one is even easier because it's not u plus 3, it's not u plus 5, or anything like that. It's just u. So I can just expand this numerator and simplify quite easily. So this is 3 times the integral of, let's see here, this cube should give us u cubed plus 3u squared plus 3u plus 1. All right. And then this is still divided by u du. There we are. All right, u cubed, right? Since this is all just over u, I can take each of these over u. So I could split this numerator up so that I have 1, 2, 3, 4 fractions. I'm not going to do that. I'm going to perform the simplification just right away. So this is 3 times the integral of u squared plus 3u plus 3 plus 1 over u du. Now I'm integrating a polynomial and 1 over u, which is just going to give me the natural log. So this is equal to, let's see here, 3 times, when I take the integral, I'm going to get 1/3 u cubed plus 3/2 u squared plus 3u plus the natural log of the absolute value of u and plus c here at the end. Now, of course, I'm not done because our original integral was in terms of x. And so I need to substitute back so that way I've got it in terms of x again. And u itself, remember, was the cube root of x minus 1. So this is equal to 3 times 1/3 of the cube root of x minus 1 cubed plus 3/2 cube root of x minus 1 squared plus 3 times the cube root of x minus 1 plus the natural log of the absolute value of the cube root of x minus 1 plus c. And that's it. Sweet. That's not so bad. Okay. Making that initial change of variables is what takes some decision making. It might be trial and error, and that's okay. Is making a substitution always obvious? No, especially when you're working with things like this, where it's not just substituting to the nice form that we have in the theorem, right? There's some substitutions, some further manipulations, and then we end up with something that's very reasonable to integrate because we're familiar with polynomials, and now we're familiar with 1 over u. Excellent. So that's all I had for this video. We'll continue on with a couple more examples followed by a theorem in our next video. So you see you back in the workshop very shortly.